Hello everyone, welcome to Chemazon-Complete Chemistry. So now we are starting with infrared spectroscopy. First topic is what are the different types of molecular vibrations. So from this image you cannot find out what exactly is this, but you will come to know in a moment. So first of all, let us understand what exactly happens in a molecular vibration. Suppose here I have taken an HCl molecule. Smaller atom is hydrogen, larger atom, green atom is chlorine. So what exactly happens is we consider these two spheres, they are connected by a bond, and we assume a bond to be a spring like this. Okay, we assume that they are attached by a spring. Okay, and what happens is when I stretch the spring, it will be in a stretched position like this. Okay, in a stretched position like this. And what will happen when I stretch and I hold it, and what I do, I release it. So when I release it, what will happen? Because of the inward force, what will happen, this will come back to its first, it will come back to its normal position like this, HCl, and then what will happen is it will compress. Okay, and this process will repeat again, that is it will expand, come back to its equilibrium position, then compress, and then it will keep on happening like this until the energy that I have provided is used out. Okay, so let us see how exactly it looks like. So you can imagine these two weights as the two atoms, and this spring is nothing but the bond between the two atoms. Okay, so this is how a vibration takes place, a stretching vibration takes place in a bond. So this is what I was trying to explain to you. So what happens is this is the equilibrium position. Okay, this is the equilibrium bond length. What I will do, first I will apply a spring force, that is called a spring force. So it will get stretched and then again it will be compressed. Okay, when it is stretched, the spring force is exactly opposite. Suppose I am applying the force in this direction, the force present in the spring is exactly opposite direction. So if I pull, that is a red arrow, if I pull outward, the spring force will pull it inward. Okay, it will get compressed and then again it will come to equilibrium position first, then it will be compressed, and this process will continue until the energy is lost. Okay, so this was about the basic idea of how a stretching vibration takes place in a bond. So now what we have to see is types of molecular vibrations. They are basically of two types. One is a stretching. So what happens in a stretching is it is a vibration along one particular line of the bond, along the line of the bond. Okay, and what happens in a stretching vibration? There is change in the bond length. What is bond length? Suppose this is hydrogen atom and there is chlorine atom. A chlorine atom also has its center, nucleus. The distance between the centers of the two atoms is nothing but the, let's say L. L is what? L is the bond length. Okay, the distance between the nuclei of the two atoms in the equilibrium positions. Remember, in the equilibrium position is called as the bond length. Okay, so there is change in the bond length during a stretching vibration. So another type is bending of the bond. So what happens in a bending? The bond length does not change. What changes is the bond angle. Okay, you will see when I bend a particular bond, you will see that bond angle changes, but the bond length will remain same. So further, there are more classifications. Let us see. Molecular vibration can be of two types. Basically, one is stretching and another is bending. Stretching, there are two types. One is symmetric stretching, another is asymmetric stretching. Now this symmetric and asymmetric is based on the direction in which I am stretching. Okay, that we'll see in a moment. Another type of molecular vibration is bending. Now bending can be of two types. If I bend a particular bond in one plane, that is called in plane bending. They are of two types. One is called scissoring and another is called rocking. Again, this scissoring and rocking is based on the direction in which I am bending the bonds. And another type of bending mode is out of plane bending. So now I don't keep both the bonds in one plane. I am moving it out of the plane, or I am bending it out of the plane. This is also of two types. One is wagging and another is twisting. So now let us one by one try to understand. First, what we are seeing is the stretching vibrations. So first is what? First is symmetric stretching. Symmetric means same. Okay, so you are stretching two bonds in same direction. As you can see here, both are directed outward, away from the central atom. Okay, this is called a symmetric stretching. And how does this look like? So you can see this is the symmetric stretching vibration in two particular bonds that you can see here, that is yellow and blue, the bonds connecting yellow and blue atom. Now let us see what is asymmetric stretching. So here you can see it is direction is opposite. Okay, the stretching of the bonds are in exactly opposite directions. Okay, so you can see the length of the bond is changing. Here also in symmetric stretching as well as in asymmetric stretching, you can see the bond length is changing. But is the bond angle changing? No, bond angle is same. Okay, so this were the stretching modes. Now what we are seeing is the bending modes. First we are seeing in plane bending. Okay, in plane bending modes of vibration. So first is what? Scissoring. What is the meaning of scissor? Okay, so this is one plane. Okay, this is a plane that they have drawn. So we are bending both the bonds in towards each other. Okay, we are bending towards each other just like a scissor. How a scissor works? Both the ends of the scissor come together, and that this mode is called as scissoring. Okay, just like how a scissor works, the bonds are bending as you can see here. This is in plane bending. First is scissoring. Another type is rocking. So rocking, again you can see it is in same plane. Now the bending of the direction of the bending of the bonds is same. This is also bending upward. Another bond is also bending upward. So you can see here, just like this man is rocking on the chair, the motion you can see. Similarly, the bonds will bend like just like this chair. You can see both are bending in the same direction. So here you can see what is happening is the bond angle is what is changing. Okay, bond angle is changing. Okay, this was the in plane. Now we are seeing out of plane. Now if I bend both the bonds in the same direction out of plane, it looks like, it is called wagging, and it looks like what? It looks like a dog is wagging its tail. Okay, similar to how a dog wags its tails, that is how it is going to look. So this is, you can see the sphere is getting bigger, means it is coming towards us. So you can see both the spheres are coming towards us at the same time, and the size is also decreasing. That means they are going away, also away from the plane also at the same time. So this was wagging, and the last mode of vibration is twisting. So you can see just how this man is twisting and dancing. Similar to that, this molecule you can see. So here out of plane vibration takes place in opposite direction. So one of the bond is bent out of the plane, that is away from the plane of the paper, like let's say towards us. So the other bond will be bending in the opposite direction, that is away from us. So you can see when the first sphere is getting larger, this is getting smaller. So both are in the opposite direction. So this is nothing but called as twisting.